Now we're going to look at different soil profiles. So, how do you start describing the soil? Maybe you can answer the question yourself. What do you see? What is the difference from top to bottom? And how deep do roots actually go? I want you guys to take a second, stop the video, and ask yourself that. All right, now that we're back, this can occur and you can start describing the soil by the changes in color, texture, etc. This is all due to different soil processes. The resulting changes cause identifiable soil horizons. It's often that you can see these changes by color, but they are also observed by the feel or texture of the soil as well. Usually with these soil horizons, the dark color is on the top due to high amounts of organic matter coating the soil particles. So a lot of that organic material is up in those top areas. Now, gray colors often mean that the soil is wet for at least part of the year. And another hint, the depth of the roots can grow, and the indicator of how deep the roots grow indicate if the soil gets hard, or if nutrients are not present, or if the soil gets too wet or too dry for the roots to survive. Now, I want you guys to really make sure you can explain the next three definitions. So that's soil profile, soil horizon, and soil layer. So the soil profile is a vertical section of the soil extending vertically through all of its horizons and into the parent material. The soil horizons is a layer of soil approximately parallel to the surface with properties that differ from the horizons above or below it. The soil properties or characteristics are produced by soil forming processes. And we're going to look at, the different horizons. That's the main part of at least this lecture. We're going to focus on that soil horizons, but looking at the big picture of it, it's the soil profile. Now, a soil layer is a layer in the soil that's deposited by a geological force, wind, water, glaciers, oceans, and are not related to soil forming processes. Now here you can look at your soil profile and the specific soil horizon. So we have at the very top is that O layer, and that's more humus and organic matter. And this is from decomposing leaves, and has a lot of that organic matter that we talked about before. And you can see how it's very dark in that O layer. That O layer is going to be very important. The next one that we go to is A, and that's the topsoil. It contains a lot of the roots and minerals for growing plants. It's a little bit lighter than the O layer. And we have E, is that alluviated layer or exit layer, and that's where the materials, minerals, organic matter, and clays exit the soil profile. B is where we get into our subsoil, and that's the minerals from the upper horizons that stop there. We have C, and that's that parent material that we discussed, and that's the Earth's surface that the soil was developed from originally. And then R, we have the bedrock. Now with this O layer, we're going to go back to the top real quick. That O layer, not all soils are going to have it. Some it's going to be very thick, some it's going to be very thin, depending how much organic matter that we have. Not all soils also have the E horizon. But these soils are usually lighter in color, but not all soils may have this layer. And in some soils, this B, the subsoil layer, is also not going to be present. Some common terms for the different layers, we have topsoil, and the first 4 inches, and then from about 5 to 23, we have the subsoil, and then below the subsoil, we have parent material. And here's that A horizon, B horizon, then the C horizon. And you can remember the ideal profile by just thinking about this. We have R and Ethel bakes cookies regularly. Okay, R and Ethel bakes cookies regularly. So just keep on repeating that back and back in your head. and then hopefully that you will remember that ideal profile. Now, in the next set of slides, each horizon will be described, but you need to remember that all horizons may not be present in any one soil profile due to how the soil was formed and where it exactly was located. Now, first we have the O horizon, and this is dominated by organic matter. It often is confused with the A horizon, so you need to figure out how to figure out the O between the A. That's that uppermost top layer. The best way to tell if it is an O is to feel it. The O will be squishy and light in weight. And if there are a lot of identifiable dead leaves from previous falls, seasons present at this time, that is a good way to tell if it's the O layer. Also, if living roots, however, do not make it in the O horizon, and that would be the A horizon. This is a thick organic or O horizon from peatlands in eastern North Carolina. This scale is not in inches, it's actually in centimeters, but the entire profile is labeled as an O horizon. No other horizons are present. So like we said before, it all depends on how the soil was actually formed. In this case, only the O horizon is present. That is all organic matter. The leaf litter at the top of the profile in the horizon is about 3 to 5 centimeters below our O horizons, and that's slightly reddish to brown in color. From 3 to 20 centimeters is an A horizon, even though it is darker in color. The A horizon may look like the O horizon, and that is very dark. The color is due to a small amount of organic matter mixed in, as well as organic matter coating particles. The A horizon may feel a little greasier than the O horizon below, but it will not be squishy like the O horizon. The A horizon is often referred to as topsoil, and it contains many nutrients that are essential for plant growth. The A horizon, or the plow layer or topsoil, is 0 to 25 centimeters, but it's pretty neat if you can look at this picture how abrupt the transition from the A to the lower horizon is. It's a complete line, which is really neat. This is due to the plowing or tillage for agriculture. This mixes the A horizon to an even depth. In a forested or uncultivated soil, the transition would be more gradual, but here, since it's going year after year at the same exact depth, that's why we're seeing such a large transition from the A to the other horizons. It's kind of crazy. Some soils may retain this abrupt change even after 10 years of not being cultivated. So that long-term effect, especially with agriculture that we see, has a longer effect than what we think. We think maybe it's just going to be cured the year later or 2 years later. No, even 10 years later, we still see that abrupt change within the soil horizons. The horizon below, that yellowish color, is the B horizon, which is 25 to 100 centimeters. And here there's no E horizon because it has been mixing in with the A horizon due to the cultivation. Next, we have the E horizon, and you can tell the difference between the A and the E horizon by remembering that A horizons have a high organic matter content. E horizons have a low organic matter content. E horizons often feel sandier and coarser than the A horizon, and E horizons are lighter in color than A horizons. You can tell the difference between E and B horizons by remembering that E horizons are sandier and coarser than B horizons. E horizons are higher in value. B horizons have more clay, and B horizons have more iron. And then we have that B horizon, and that is referred to as the subsoil, the zone of accumulation within the soil. And the B horizon is at about 40 centimeters and continuing on to about 100 centimeters and has a higher clay content than the E horizon as well. The C horizon is called the parent material, and unlike the A, E, and B horizons, C horizons generally lack soil structure.